Welcome back, everyone. It's now time to begin data pre-processing, and we'll start off by trying to figure out how to work with the missing data in our data set. This is probably the hardest part of the entire project because it's more nuanced and there's no 100% correct answer. Remember, our options are to either keep the missing data, drop the missing data, or fill in the missing data. Let's review what data is missing and how we can work with it. All right, so to begin section 2 on data pre-processing, we have a couple of goals, and right now we're going to focus on either removing or filling in any missing data. And this very first cell actually isn't a task, it's just the head of the data frame that we currently have. So we'll move on to missing data, and we want to ask ourselves, what is the length of the entire data frame? And that's easy to answer just by saying len on the data frame. You could also use df.info, and it looks like we have about 400,000 points, a little less than that. So next we want to create a series that displays the total count of missing values per column. And we've shown you how to do this before. You simply say df.isNull, and recall that returns back a data frame that looks like this, and we can take the sum of this across the rows here, and then we get the actual columns and their numbers for how many points are missing. So it looks like we have around 22,000 missing for emp title, which we'll later find out is employment title. Also employment length is missing quite a bit. Then we have this titles missing, just a few missing on this particular feature. We're missing quite a bit on mort ac, so we'll have to see what that is. And then we're also missing a couple on any public record of bankruptcies. Okay, so what would be interesting is to get these numbers in terms of percentage of this total data frame, just to see how significant of a problem is it. So I want to see it in this fashion of, I'm missing 5.7% of all employment titles, or I'm missing almost 10% of these mortgage accounts. So let's go ahead and figure out how to do that. One way to do it is to get our previous series. Recall that is df is null dot sum, and then if I simply divide every item there by the length of the data frame, I can then multiply that by 100 to get a percentage. And that is how we can get this exact same result. So again, it's 100 times df is null dot sum divided by the length of the data frame. So it looks like the ones we're going to have to really focus on is this mortgage accounts, because we can't just really drop 10% of our data. But some of these are so minor, such as this one and this one. These are actually less than 0.5% of our data. So it should be fine to drop some of these. So what we're going to do is we're going to start from the top to the bottom. We'll start off with this employment title and employment length. So let's scroll down here. So I want to first examine this employment title and employment length to see whether it will be okay to drop them. So we can use feat_info. That's the feature information function that we set up for you at the beginning that simply reports back what these are. So the feature information on the employment title, that's simply the job title supplied by the borrower when applying for the loan. And the employment length one, we actually have it for you here. It's the employment length in years. So possible values are between 0 and 10, where 0 means less than 1 year and 10 means 10 or more years. So next question that we want to start thinking about is, well, how many unique employment job titles are there? Because we want to start thinking, are we just going to drop employment title or fill it in with something? So it might be interesting to actually explore the employment title. So we'll say df employment title, and let's just see how many unique employment titles there are. So after running that, you should see there's a ton of unique employment titles. In fact, there's 173,000 unique employment titles. Recall that our data set itself was around 400,000. So it looks like there's almost half of that are all unique employment titles. And then we can kind of check it out with a value counts to explore that further, which I would recommend. Although you don't have to do this for the project, we can simply run this. And we can see here that we have some teachers, managers, registered nurses, etc. And we have a ton of titles that are actually just unique to that particular person. So realistically, there are just way too many titles to convert this to some sort of dummy variable feature. We can't add in an extra 173,000 columns of booleans. Now what you could do is maybe with extensive feature engineering, start categorizing these, maybe as high income jobs versus medium income jobs. But again, you'll have to make a lot of assumptions, and you have to figure out how to do this and map it to over 173,000 different job titles. So this is just so many unique job titles that it's probably not going to be very informative because half of all people have some unique job title. So instead what we're going to do is we'll simply remove that title because it's not realistically going to be useful to us in any manner. So we'll say df is going to be equal to df.drop the employment title, and we need to do this along axis is equal to 1. And be careful with these dropping statements because you can only run them once. If you try running them more than once, you'll end up getting an error because you already removed that feature. Okay, next we want to create a count plot of the employment length feature column. So again, we want to try to sort the order of the values. So one way to do that is to try to grab a list here in order to actually get that order. So we can say, just as before, df employment length, should be an underscore. Go ahead and say drop NA, and after that we should be able to call unique. If we don't drop NA, sometimes that returns an error. So here are the actual unique titles, and I'm going to just go ahead and sort them. And now I have the sorted titles, and this actually looks almost in order, except it accidentally sorted 1 year right before this 10 plus years. So what I can do is simply copy this, which is what I was doing down here, paste it into this cell, and we'll go ahead and say employee length order is equal to this list, and then I'll simply adjust this by grabbing this guy, sticking it down here. Let's go ahead and make sure that formatting is correct. And then we'll grab this guy and stick it there. And then fix the commas. Okay, so after running that, we now have this nice ordering. Again, this is technically optional, but it'll be nice for our count plot that we create right here to have this actually in order. And now I can do this by simply saying SNS count plot, where X is the employment length, my data is equal to my current data frame, and my order is equal to that employment length order. So if you run that, you get to see this right here. We'll go ahead and stretch it out so we don't get that overlapping by saying PLT figure, fig size is equal to, go ahead and say 12 by 4, and we get this nice plot here. So it looks like quite the majority of people have been working in their employment for 10 plus years, which makes sense. If you're taking a loan, you're very likely to have a job. Otherwise, how are you going to pay it back? So most people have been working for more than a year. And it looks like we messed up the order here of 1 year versus less than 1 year. So let's go ahead and take this guy and put it right there where it belongs. And then that should fix the ordering for us. There we go. So now we see the less than 1 year, 1 year, 2 year, etc. Okay. So something I may also want to do is just view how useful of a feature this is based off what we're trying to predict. Recall that we're trying to predict whether or not someone's actually going to pay back their loan. So what is their loan status? We run that, and really what I'm interested in here is the relationship between fully paid off versus charged off per employment length. If there's an extreme difference in one of these categories of fully paid off versus charged off, for example, maybe if you worked less than 1 year, everyone there charged off their loan, didn't pay it back, then it's a very important feature. If the ratio of this blue bar to this orange bar is essentially the same across all these employment length categories, then this isn't a very informative feature. So what I want to do is I really want to figure out the ratio between the fully paid off versus charged off people per category of employment length. And that's what this later task, we just completed this one down here, this task right here, that's what it's essentially describing. So that doesn't really inform us. What we really want to know is the percentage of charge-offs per employment length category. Okay, so how can we actually do this? This is a bit of a challenge task, but if you just think of this logically step by step, especially when you're using pandas, it should be pretty straightforward. So what I want to do is I essentially want to build out a series that looks something like this. The percent of people that don't pay back their loan per employment category. So what I'm going to do is I'll say, go ahead and grab the subset of the data frame where my loan status is equal to charged off. So these are the people that did not pay back their loans. And I'm going to copy and paste this down here because we'll do the same thing for people that did fully pay off their loan. So I have right now one data frame where people didn't pay back their loan, charged off, and the one where they fully paid it. And what I'm going to do is I'm interested in grouping it by this employment length category. So I will say group by employment underscore length. And I'll do that for both cases. And next what I want to do is I actually want to grab the counts for each of them. I want to figure out how many people are actually in this blue bar and how many people are in this orange bar. So essentially I'm just trying to do the math behind these bars. So the charged off people, group them by employment length, go ahead and do the count there. That essentially now is this orange count column. And to get the blue count column, we'll just do that on the fully paid statuses. And in this case, I'm really only interested in the loan status column for each of these. So instead of just running this and getting the amounts, since it's going to be the same for all these, I'm just going to pass in a column of loan status and get those numbers. So here I can see the loan status for the charged off per employment category. And then if I do this on this guy, I'll get the same thing, but for people that fully paid back their loans. And I'm going to assign these by saying employment or EMP underscore, we'll go ahead and say CO for charged off. So that's one series. And then we'll say EMP underscore FP for fully paid. And then all I'm interested in is the ratio between them. So that would be the employee length for people that charged off divided by the fully paid. So we can run these, and now I can see the percent of people that charged off versus the fully paid. Keep in mind, this is a direct ratio. If I actually wanted the percent, I could say EMPCO plus EMPFP, run that, and then this is the actual percent per category instead of the direct ratio. And we can see here that across the extremes, it looks to be extremely similar. So I can see 0.19, 0.18, most of these are 0.19 versus the max of 0.2. So it looks like this particular feature of employment length doesn't actually have some extreme differences on the charge-off rates. So it looks like regardless of what actual employment length you have, if you were to pick someone, about 20% of them, somewhere between 19% or 19.99 and 20% are going to have not paid back their loans. And we can just exemplify this further by, if we say employment underscore length, I can then actually make a bar plot for this. By saying plot kind is equal to bar, run that, and I can see the percentages or the ratios, essentially the same information. Really what I'm looking for here is the fact that since all these bars are almost the same height, there really isn't that much information or differentiation between the employment length columns, which is kind of surprising, but we can see here the main difference is that people who work for 10 years have a slightly smaller charge-off rate than people who worked less, like 1 year or less than a year. But the difference is not extreme enough to really validate keeping this feature. So since they're so extremely similar across all employments, what we'll go ahead and do is just drop that column. We'll say df is equal to df.drop employment length axis equal to 1. So run that, and next revisit the data frame to see what feature columns still have missing data. So we'll say df is null dot sum. Go ahead and run that. You'll get back this series, and it looks like we still have the title, this revol util, this mortgage accounts, and the public record bankruptcies. So we'll go ahead and continue dealing with these remaining missing features in the continuation of this lecture. I'll see you there.